In this video, we'll be factoring the sum and difference of cubes. Before we start with an example, let's look at the rules. If you have the sum of two cubes, that factors into a binomial, which is two terms, multiplied by a trinomial, which is three terms. Our binomial will have a plus sign in between the terms because I have a plus here. And then the operations back in the trinomial are minus and plus. It's always this way. Okay, if it's the sum of two cubes, you'll always have a plus in the front and then a minus plus. If you have the difference of cubes, your binomial will be a subtraction, and then the trinomial will both be pluses. Now the terms themselves, in the binomial, we're going to cube root these terms. So the cube root of x cubed is x, cube root of y cubed is y. That's the same for the difference of cubes. So those are both x and y. And then for my trinomial, my first term is the square of this first term. So x squared. My last term is the square of this, so y squared. And the middle term is the product of these two, so x times y. And the terms are the same for the trinomial in the back of my difference of cubes as well. So x squared, xy, and y squared. So this is the rules for factoring the sum and difference of cubes. Now let's apply that to an example. We're asked to factor x cubed y to the sixth minus p cubed. I know these are cubes because all of the exponents are multiples of 3. So I'm going to start with, I have a binomial and a trinomial. Because this is the subtraction, I have a minus in between my terms on the binomial, and then on the trinomial, they're both going to be pluses. Now when I cube root x cubed, I get x. When I cube root y to the sixth, I get y squared. Now let's look at why that happens that way. A cube root of y to the sixth. Remember, we can write a radical with a fractional exponent. So this is the same as y to the sixth divided by 3. And 6 divided by 3 is the same as 2. So y squared. Basically then, whenever you want to cube root an exponential, just divide your exponent by 3 to cube root. So I've already done my cube root of x cubed. The cube root of y to the sixth, I want to divide this exponent by 3. So I have y squared. And then the cube root of p cubed, again divide this exponent by 3. I have p to the first power. Alright, once I've done my binomial, then my first term of the trinomial is going to be this term squared. So when you square this product, you square each of the factors. So x squared, and then y squared squared means I'm going to multiply those exponents, so y to the fourth. My middle term is the product of these two terms, so just x y squared p. And notice that I don't think of this as a minus p. It's just take the factor itself. Just take the term. And then square my last term, so p squared. This is my factored form of this difference of cubes. Let's look at another example. Let's factor 8m to the third y to the sixth plus x to the 12th. Again, I know that I have cubes. 8 is 2 times 2 times 2. And all of these exponents are multiples of 3. So I know that I have the sum of cubes. So I can factor this. And I have a binomial and then a trinomial. Nice long one. My signs in each of these expressions, since this is plus, I'm going to have a plus in the binomial, and then in my trinomial I'm going to have a minus and a plus. The cube root of 8 is 2. The cube root of m cubed is m. And then I'm going to divide this exponent by 3 to get the cube root of y to the 6th power. 6 divided by 3 is 2, so this is y squared. And then the cube root of x to the 12th, I want to divide this 12 by 3. 12 divided by 3 is 4, so the cube root of x to the 12th is x to the 4th. Alright, now to get my terms in my trinomial, I'm going to square each of these. So 2 squared is 4, m squared, y squared squared, and then for my middle term, I'm going to multiply these two together. So 2my squared x 4. And then for this last term, I'm going to square x to the 4th. X to the 4th squared is multiply exponents. So this is x to the 8th. So this is my factored form.